Some of the most valuable white minerals on Earth can look surprisingly ordinary, pale, translucent, sometimes almost indistinguishable from quartz. But exceptional examples can be worth more than 5 times their weight in gold. At today's benchmark, that means crossing roughly $149 per carat, and number 10 only just makes it. From there, the gap gets much wider. These are 10 white minerals where rarity, quality, and geology can turn an ordinary-looking crystal into something worth far more than gold. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Number 10. Danburite, the quartz, look-alike that just crosses the gold line. At first glance, there is almost nothing here that suggests serious value. A pale crystal, glassy luster, little or no color. Placed beside a clean piece of quartz, many people would struggle to see why one deserves a second look. But this is not quartz. It is Danburite, and exceptional examples can cross the line this entire countdown is built around. 5 times the value of gold at the same weight. At the gold price used for this comparison, 1 carat of gold equivalent weight is worth roughly $30. Multiply that by 5, and a gemstone must reach approximately $149 per carat to qualify. Upper-end Danburite can move beyond $150 per carat. Not dramatically, just enough. And that is exactly why it belongs at number 10. Danburite is a calcium-boron silicate that can occur colorless, white, or in very pale shades of yellow and pink. Its crystals range from transparent to translucent, and with a hardness of roughly 7 to 7.5, it can survive well enough to become an attractive faceted gemstone. But the real story is not the mineral itself. It is the quality filter. Most Danburite is nowhere near the 5 times gold threshold. Common material may be too included, too fractured, too small, poorly colored, or simply too ordinary to attract serious collector premiums. To reach the upper end, several things must happen at once. The crystal must be unusually clean. It must offer enough usable size. The material must transmit light well. And after cutting, it must retain the brightness and visual precision that separate fine gem Danburite from an ordinary mineral specimen. That combination is much harder to find than the name Danburite suggests. Quartz exposes the difference perfectly. Quartz can also be white or colorless. It can also form attractive transparent crystals. It can also take a beautiful polish. But quartz occurs on an enormous geological scale. Fine Danburite does not. So 2 stones may look surprisingly similar in the hand while occupying completely different levels of the market. That is the first rule of this countdown. Never confuse familiar appearance with familiar value. Danburite only barely crosses the 5 times gold line. Number 9 will not be nearly as close. Number 9. Rhodizite. Danburite looked enough like quartz to be underestimated. Rhodizite makes the mistake even easier. In its palest form, this mineral can appear creamy white, nearly colorless, and translucent to transparent, with a bright glassy surface. A small rough crystal mixed into a tray of pale minerals might attract almost no attention. Yet fine rhodizite can cross the 5 times gold line with room to spare. At the benchmark established earlier, a gemstone needs to exceed roughly $149 per carat to be worth 5 times the same weight in gold. Faceted rhodizite can sell from modest collector prices to around $550 per carat at the upper end. At that level, 1 carat of rhodizite carries roughly 18 times the value of the same weight in gold. So why can something this visually quiet become so expensive? The answer begins underground. Rhodizite is a rare beryllium-bearing baryte mineral that forms in highly evolved granitic pegmatites, the same extraordinary geological environments capable of producing tourmaline, beryl, spodumene, and other collector minerals. But finding rhodizite is not enough. Finding faceable rhodizite is the real problem. The mineral reaches about 8 on the Mohs scale, making it harder than quartz, but crystals suitable for cutting are typically small and often contain fractures, growth features, or other inclusions. Fine, clean material large enough to produce a convincing gemstone represents only a narrow fraction of what nature creates. Madagascar illustrates just how narrow that fraction can become. GIA documented important rhodizite lundonite material from central Madagascar, where roughly 300 carats were faceted from one notable deposit during years of mining. Even among collector gems, that is an extraordinarily limited amount of documented production. And now compare that with quartz. Quartz occurs across the planet in enormous quantities, forming crystals that can weigh kilograms or far more. Rhodizite gem rough is commonly measured in fractions of a carat. That is the difference hidden behind the white surface. The eye sees another pale crystal. The market sees a mineral that is difficult to find, harder to find clean, and rarer still in faceable size. Danburite barely crossed the gold line. Rhodizite can move far beyond it. And number 8 proves that even a larger white crystal can hide the same kind of financial surprise. Number 8, natural white spinel, the colorless gem hiding behind a famous name. A pale crystal like this creates an immediate problem. There is no rich red color to identify it, no royal blue, no obvious feature announcing that it belongs to one of the great gemstone families. In rough form, a white or nearly colorless specimen could be passed over as quartz, topaz, or simply another transparent crystal. But this is natural spinel, and unlike the inexpensive synthetic white spinel found throughout the jewelry trade, genuinely colorless natural material is remarkably uncommon. More importantly for this countdown, fine examples can cross the gold line easily. Our 5 times gold threshold sits at roughly $149 per carat. A current Burmese colorless spinel weighing 1.35 carats is offered at about $275 per carat, more than 9 times the value of gold at equal weight. Other exceptional natural white spinels can climb far higher. One 1.63 carat Sri Lankan example has been listed above $3,400 per carat. That does not mean every white spinel is worth thousands. Far from it. The difference begins with one word: natural. Spinel is magnesium aluminum oxide, MgAl 204, with a hardness around 8 and excellent durability. The mineral is famous for reds, pinks, blues, and violets because trace elements alter its color. Remove those coloring influences, however, and nearly pure colorless spinel can emerge. Nature simply does not produce much gem-quality material like this. Even dealers specializing in rare stones describe truly colorless natural spinel as something encountered far less frequently than the better-known red and blue varieties. And that rarity becomes more severe once quality enters the equation. A valuable stone must still be large enough to cut, sufficiently clean, naturally pale rather than artificially modified, and attractive enough after faceting to justify a collector premium. Quartz faces none of those supply constraints on the same scale. Large, clean rock crystal occurs in deposits across the world. Natural, colorless spinel occupies a much narrower corner of the gem market, so the resemblance can be deceptive. One pale crystal may be ordinary quartz. The other may be a natural spinel worth many times more than the same weight in gold. Rhodizite proved that tiny crystals could hide extraordinary scarcity. White spinel reveals something even more dangerous. Sometimes the familiar gemstone name is hiding its rarest color of all. Number 7. Herderite. A small pale crystal appears in a mineral tray. It is glassy, nearly colorless, sometimes slightly greenish-white, and transparent enough at the edges to resemble a piece of ordinary quartz. Nothing about it immediately suggests serious value. But this is Herderite. And with current specialist listings around $320 per carat, fine material can be worth roughly 10 times the same weight in gold, more than double the threshold required to enter this countdown. Yet price is only the beginning of what makes Herderite unusual. Herderite is a calcium beryllium phosphate containing fluorine. It forms mainly during the late stages of activity in complex granitic pegmatites, environments where unusual combinations of elements can become concentrated into minerals that rarely form anywhere else. Its color can be nearly absent. Its luster can look familiar. And at 5 to 5.5 on the Mohs scale, it is actually softer than quartz. So appearance and hardness provide almost no warning of what may be sitting in the hand. Then comes the real complication. Many crystals historically labeled Herderite are not true Herderite at all. They are hydroxyl herderite, a closely related mineral in which hydroxyl replaces much of the fluorine. The two can look so similar that a label alone cannot always be trusted. Modern mineralogical data indicate that confirmed fluorine-dominant herderite is known from a surprisingly restricted group of localities. That distinction changes the rarity equation completely. Finding a pale pegmatite crystal is one thing. Finding material clean enough to facet is harder. Finding material that is genuinely herderite and not merely something visually similar is another filter again. Now place it back beside quartz. The current market index used for this comparison lists quartz around $14 per carat. Herderite sits near $320. The eye may see two pale, glassy minerals. The market can see a difference of more than 20 times. And against gold, herderite does something Danburite at number 10 could only barely achieve. It does not merely cross the 5 times gold line, it clears it comfortably. Because with rare white minerals, sometimes the most valuable detail is not visible in the crystal at all. Sometimes it is hidden in the chemistry, and number 6 pushes that scarcity even further. Number 6, Hambergite, the white crystal that makes quartz look cheap. Under ordinary light, Hambergite can be almost disappointingly plain. No dramatic color, no metallic flash, no optical phenomenon sweeping across the surface. A clean crystal may be colorless, grayish-white, or faintly yellowish, with the same vitreous luster seen in countless pieces of quartz. In rough form, especially at a glance, there may be very little suggesting that this pale mineral belongs in a discussion about gold. But fine Hambergite can reach a completely different level of value. With the 5 times gold threshold sitting near $149 per carat, documented collector gem sales around $420 per carat place, exceptional Hambergite at roughly 14 times the value of the same weight in gold. And unlike Danburite at number 10, Hambergite does not merely scrape across the line. It clears it decisively. The reason begins with geology. Hambergite is a rare beryllium barotte, Be2Bo, 3 open, parenthesis O, H close parenthesis, most often associated with highly evolved granitic pegmatites. These geological systems can concentrate unusual elements into pockets where rare minerals crystallize. But those pockets are limited, unpredictable, and often small. Even then, finding Hambergite does not guarantee a gemstone. The mineral can be transparent to translucent and reaches about 7.5 on the Mohs scale, slightly harder than quartz. But it also has perfect cleavage and brittle tenacity. A crystal may look promising in the rough and still contain fractures, cleavage weaknesses, or internal features that dramatically reduce the amount of material suitable for fasting. That is where the supply narrows. A collector-quality crystal must first form. A gem-quality section must survive inside it. Then enough clean material must remain to justify cutting. GIA's gem collection includes colorless, faceted Hambergites exceeding 5 carats, but stones of that scale are hardly ordinary commercial material. Now place one beside rock crystal. Quartz can form in enormous masses and spectacular crystals across countless geological environments worldwide. Hambergite does not have that luxury. The visual difference may be subtle. The geological difference is enormous. And that is exactly why this countdown exists. A white crystal does not become valuable because it looks exotic. Sometimes it becomes valuable because nature had to create a very unusual set of conditions just to produce a few clean carats. At number 6, Hambergite pushes the gold comparison beyond 14 times. From here, the gap becomes much harder to ignore. Number 5, natural white sapphire. Most people hear the word sapphire and imagine blue. That expectation is so strong that a pale crystal with almost no color can be dismissed before anyone asks the most important question: what if it is still sapphire? Natural white sapphire is colorless or nearly colorless corundum, the same mineral family that produces blue sapphire and ruby. GIA confirms that colorless corundum is known in the trade as white sapphire, and fine untreated material can move far beyond the gold line. The benchmark for this countdown is approximately $149 per carat, 5 times the value of the same weight in gold. A GIA-certified, Unheated Sri Lankan white sapphire, weighing 8.09 carats, was listed at $950 per carat before selling. That works out to roughly 32 times the value of the same weight in gold. But this is where the comparison becomes important. Not every white sapphire is worth anything close to that amount. Smaller stones, included material, poor cutting, or treated gems, can occupy much lower price levels. Current examples of untreated Sri Lankan stones show prices ranging from around $280 per carat to $450 per carat and beyond, depending on quality. So what pushes an exceptional stone toward the upper end? Size is one filter. Clarity is another. Cutting must preserve brilliance without wasting too much rough. And treatment history can matter enormously. Heating sapphire is widely accepted in the gem trade, but GIA notes that for fine quality stones, independent confirmation that no evidence of heat treatment is present can add both rarity and value. That makes large, clean, untreated white sapphire a much narrower category than the name suggests. Now compare it with quartz. Both can be pale, both can be transparent, or nearly so. Both may look surprisingly modest before cutting, but quartz has a Mohs hardness of 7. Sapphire reaches 9, second only to diamond among the major traditional jewelry gemstones, and more importantly, quartz occurs on an enormous geological scale. Exceptional, untreated white sapphire does not. That is why number 5 changes the tone of this countdown. The first minerals crossed the gold line because collectors valued their rarity. White sapphire shows what happens when rarity, durability, size, clarity, and documented natural history arrive in the same stone. It may have almost no color, but at the highest level, there is almost nothing ordinary about it. Number 4. Leuco grossular garnet, the garnet with no color. Mention garnet, and red is almost automatic. Deep crimson crystals have carried the name for centuries. Green Sapphirite pushed the family into luxury jewelry. Orange Hessonite created another recognizable identity, but strip away nearly every trace of color, and garnet becomes much harder to recognize. This is Leuco grossular garnet, an exceptionally rare colorless to near colorless variety of grossular. And a fine example can be worth far more than 5 times its weight in gold. The benchmark for this countdown is roughly $149 per carat. A current 3.97 carat natural Leuco grossular is offered at approximately $1,100, or about $277 per carat. At that level, the stone is worth more than 9 times the value of the same weight in gold. But the price makes sense only when the rarity is understood. Grossular is a calcium aluminum garnet, Ca3Al 2 open parenthesis, SiO 4 close parenthesis 3. Most examples contain trace elements that create green, yellow, orange, or brown coloration. Leuco material is different. The word leuco means white or colorless, and true Leuco grossular contains so little color-producing chemistry that the stone can appear almost completely clear, white or faintly tinted. That sounds simple. Geologically, it is not. Gemological studies describe colorless grossular as rare and sought after by collectors, with documented occurrences from only a limited number of deposits. Even when grossular forms, most crystals do not emerge simultaneously near colorless, clean, large enough to cut, and attractive enough to become fine gemstones. Size makes the filter even narrower. Leuco garnets are frequently small, and clean stones above a carat are particularly difficult to encounter. Larger, near-colorless examples therefore attract attention precisely because nature seldom produces the combination. Now place one beside rock crystal. Both can appear pale, both can transmit light, both can show a clean, glassy luster. But quartz is one of Earth's most widespread minerals. Colorless grossular is an exception inside a gemstone family, normally defined by color. That is what number 4 reveals. Sometimes value rises not because nature added something spectacular, but because it left almost everything out. And the final 3 minerals make this kind of scarcity look almost common. Number 3, fine white jadeite, when translucency becomes the value. At first glance, fine white jadeite can look less impressive than almost every mineral already seen. It does not throw rainbow fire. It does not need sharp facets. And beside a piece of milky quartz, a pale translucent fragment can appear surprisingly ordinary. But this is where appearances become expensive. Fine white to nearly colorless jadeite, often called ice jade in the Asian market, can rise far beyond the 5 times gold threshold. And unlike most gemstones in this countdown, the reason is not primarily brilliance, it is translucency. GIA identifies color, transparency, and texture as the 3 dominant quality factors in jadeite. The best material allows light to penetrate beneath the surface, creating a soft internal glow rather than simply reflecting light back toward the eye. Fine texture makes that effect cleaner and more even. That combination can transform a plain-looking white stone into something exceptionally valuable. The market has demonstrated just how dramatic the difference can become. GIA documented colorless, near-transparent jadeite rough that rose from about 30,000 yuan per kilogram in 1991 to as much as 10 million yuan per kilogram by 2010. That historical peak works out to roughly 2,000 yuan per carat of rough material, comfortably beyond the gold threshold used in this countdown, even before the stone was cut or polished. But most white jadeite is nowhere near that level. Coarse texture destroys the glow. Cloudiness reduces transparency. Fractures can ruin an otherwise promising section. And treatments such as bleaching and polymer impregnation can dramatically change how material must be evaluated. The premium belongs to fine natural material, where translucency, texture, size, and structural integrity survive together. Now compare it with quartz. Milky quartz can also be white. It can also transmit light around thin edges. It can even display an attractive soft glow after polishing. But quartz is produced across enormous geological environments around the planet. Fine translucent jadeite occupies a much narrower window of quality. That is why number 3 matters. The eye sees a pale stone. The market sees how deeply light can enter it. And with fine white jadeite, a few extra millimeters of translucency can separate ordinary material from something worth many times its weight in gold. Number 2, white euclase, the crystal that survives against the odds. At first glance, white euclase can look almost too ordinary for this position. A pale crystal, glassy luster, little or no color. In rough form, it can sit beside quartz without immediately revealing why the two should belong to completely different markets. But this is euclase, and fine white material can move far beyond the gold line. The benchmark for this countdown is roughly $149 per carat, 5 times the value of the same weight in gold. Current specialist listings for white euclase show how quickly exceptional material can clear it. One 4.04 carat white euclase has been offered at about $4,056, or roughly $1,000 per carat. That is more than 33 times the value of the same weight in gold. The reason is not simply that euclase is rare, it is that usable euclase must survive a brutal series of filters. Euclase is a beryllium aluminum hydroxide silicate, BeAlSiO4OH. It can be colorless or white, with transparency ranging from transparent to translucent, and it reaches about 7.5 on the Mohs scale. That sounds durable, but hardness is deceptive. Euclase has perfect cleavage in one direction and brittle tenacity. A crystal can resist scratching better than quartz and still split along a structural weakness during recovery, handling, or cutting. So a valuable white euclase must first form in a rare geological environment. It must grow large enough to matter. It must remain clean enough to transmit light. It must survive extraction. And then a cutter must orient and fast-set it without allowing that perfect cleavage to destroy the stone. Each stage removes material from an already limited supply. That is where quartz becomes the perfect comparison. Quartz can also be colorless, white, glassy, and translucent, but it occurs across the planet in enormous quantities and routinely forms large, clean crystals. White euclase does not. The eye may see 2 pale minerals. The market sees 2 completely different probabilities of nature ever producing them again. That is why euclase belongs at number 2. It does not beat gold because it looks extraordinary. It beats gold because an ordinary-looking white crystal has survived an extraordinary chain of geological and human risks. And number 1 removes even the last trace of transparency from the illusion. Number 1. Natural fancy white diamond. After 9 pale minerals, the final stone creates the strangest illusion of all. It can look milky, clouded, almost translucent. Placed beside ordinary white quartz, it may appear less brilliant than the diamond most people would choose from a jewelry case. Yet this is not an inferior colorless diamond. It is a natural fancy white diamond, and exceptional examples can be worth well over 100 times the value of gold at the same weight. That distinction matters. A normal D to F diamond is called white, casually in the jewelry trade, but gemologically it is colorless. Fancy white diamond is something entirely different. GIA explains that its whitish, sometimes opalescent appearance is generally created by enormous numbers of microscopic to nanoscopic inclusions and structural features that scatter light inside the diamond and reduce its transparency. The result can range from hazy and milky to distinctly translucent. Normally, inclusions reduce the value of a diamond. Here they create the phenomenon collectors are paying for. And the gold comparison becomes extreme. The 5 times gold threshold in this countdown is roughly $149 per carat. A currently offered GIA graded 1.23 carat. Natural fancy white diamond is priced at $6,250, about $5,080 per carat. At that level, each carat carries roughly 170 times the value of the same weight in gold. Other current fancy white diamonds show similarly extraordinary premiums, with GIA-graded examples above 2 carats offered for several $1,000s per carat. But rarity, not simply the word diamond, drives this market. Fancy white diamonds occupy an unusual corner of natural diamond formation. In GIA's major study of roughly 500 such stones, the vast majority belong to the rare Type 1 AB category, and researchers concluded that many probably form more than 250 kilometers beneath Earth's surface. That brings the entire countdown back to quartz. Both can appear pale, both can be cloudy, both can transmit light without being perfectly transparent, but one is produced abundantly throughout Earth's crust. The other requires an extraordinary combination of deep Earth formation and microscopic imperfections, and that is the final lesson. Sometimes the feature that makes a gemstone look less perfect is exactly what makes it almost impossible to replace. Quartz was never the problem. The problem was assuming that a pale crystal must be ordinary. Across these 10 minerals, the real difference was hidden in rarity, chemistry, clarity, size, and the tiny fraction of material nature produces at exceptional quality. Gold gave us the benchmark, but the stones proved something more interesting. Value is not always visible. Sometimes the most expensive crystal in the room is the one nobody notices first. And that is exactly why looking beyond quartz matters.